Here we go. 12.3 notes. We are going to talk about completing the square. So in 12.1, I know we've kind of skipped around. We talked about graphing circles. Um, this section is going to be a little bit more algebraic, but this is going to help us plot circles and what circles look like. Now, anytime you hear the word completing the square, it has to do with quadratics. And if we want to think about quadratics, they always look like we call the standard form. We have ax squared plus bx plus c. This equals 0. All right, this is the standard form of a quadratic. And a lot of times in this class and your Algebra 1 class, you've been factoring stuff. All right, we take these things and we try to take these, here, for example, if I have something like x squared minus 3x plus 2 equals 0, and I say factor that. All right, you would do x minus 2 and then x minus, how about x minus 1, right, equals 0. So that is a factored equation. So the ax squared plus bx plus c equals 0. Your a is a 1 in this case, your b is a negative 3, and your c value is a 2. All right, so that's just what your quadratics look like, and this is factored. Now, more times than not, polynomials do not factor, and we need other methods, other ways of solving these quadratics when they do not factor. All right, and this is just one of those ways. And really, what we have to make sure is this a term here. We have to make sure that that very first term is equal to 1. All right. And if it's not, make it equal to 1. All right, so you would divide both sides by a number if you can, that sort of thing. All right, now, step number 2, after we make sure that a value is equal to 1, we have to move the constant term to the other side of the equation. All right, and this is kind of counterintuitive because every time we factor, we want this thing to be equal to 0, not in this case. All right, we want to take that c value, the constant, oops, and we want it to, we want to put it on the other side of the equation. So this guy right here, move it over. All right, step number 3, this where it gets kind of weird. We have to take half of the coefficient in front of the x term, so half of b. I'm just going to say half of b. And then after that, we need to square it. All right. Then once we square it, we want to add it to both sides of the equation. All right. So on one side, we're going to have some kind of polynomial term, and then on the other side, we're just going to have some random number. All right. Now, after we have done all of that, we want to factor the new perfect square trinomial. All right. So one side is going to look like a trinomial. The other side is just going to be that number. All right, so first things first, if I take this polynomial, this x squared plus 14x, what I need to do is I need to figure out, hey, what is that c term going to look like in order for me to factor this? So remember, we go ax squared plus bx plus, in this case, plus our c. We are trying to figure out what is that c value. And to do that, we take the 14, we take that b value, and we are going to cut it in half. All right, so I'm just going to say divide by 2, and that gives us a 7. Now, after we cut it in half, we need to square it. All right, so I'm just going to say 7 squared. What is 7 squared? I'm just going to throw that up top. 7 squared is 49. Right? And now we have this new trinomial, this x squared plus 14x, x squared plus 14x plus 49. All right, that is a trinomial that we can factor. If you look at this guy, What times what makes 49? That also adds up to a 14. Well, if you look, it's plus 7 in both of these spots here. Now we have x plus 7 times x plus 7. What we are going to do is we are going to rewrite this as, hey, that's the same thing times itself. So therefore, this is x plus 7 squared. All right, and that one's done. That is what we call completing the square. All right, so let's do it again. First things first, look at that b value. It's a negative 40 this time. So cut it in half. Negative 40 divided by 2, that just gives us negative 20. Be careful on those signs there. So it's negative 20. The next thing we do is we square it. So we have to do negative 20 squared. What is negative 20 squared? Negative 20 squared is just 400. All right, so now we can factor this. This new trinomial, I have a squared minus 40a plus 400. Forgive my handwriting on that one. This is going to factor down to a minus 20, a minus 20. All right, and hey, it's the same thing, a minus 20, and it should be the same thing. Anytime you do this, you need to have the same two terms being multiplied by themselves. So this turns into a minus 20 squared. All right. Now, you might have noticed this already. This term right here is always going to be the same as that half of the b value, right? So if you look at this one, we had negative 20 after we chopped the 40 in half, we had negative 20, and that is what's left over right here. So you can almost, if you are comfortable doing this, you can almost skip this entire step. You can go straight from here down to there, if you are comfortable doing this. But if you want to factor it all out, then by all means. All right. So now let's actually do one of these problems here. They're saying solve this equation by completing the square. So if we look at this, all right, this problem does factor. All right, so I'm going to call this x minus 11 and x plus 1. All right, that gives me x equals 11 and x equals negative 1. All right, so we already know what the answers are going to be. However, the whole purpose of this is what if it does not factor? Okay, so that's why we do this completing the square. It works no matter what you do. So let's try that completing the square method and see what happens. So first things first, step one said add the constant term to the other side. So I'm just going to add an 11 to both sides here. So we have x squared plus 10x. Now here's what I'm going to do. I'm going to say plus a blank spot. All right, we have to figure out what number is going to go in there. Equals 11 plus another blank spot. We have to figure out what goes in that space right there. Well, how do we do that? All right, we're just going to do the same exact thing we did up top here. We have to take that b value and we have to chop it in half. All right, so 10 divided by 2 gives us a 5. Now we take that 5 and we're going to square it. So we have 5 squared. All right, and now we said we have to add it to both sides because if I add a random 25 on the left side of this equation, then I also have to add it to the right side. Remember, the most important rule in algebra, whatever you do to one side of an equation, you have to do to the other side, right? So this is what that completing the square looks like. We took the 10, cut it in half, and we got a 5. 5 squared gave us 25, so we're going to add a 25 on both sides of our equation. So here's what we have now. We have x squared plus 10x plus 25 equals 36. All right, now from here, it's very tempting to subtract the 36 on both sides. But if you do that, we're just going to end up right back to where we started. So do not do that. When we're completing the square, you do not want to do that. All right, so now what we need to do is we need to factor this new trinomial. So we're going to have x plus 5 times x plus 5. That all equals 36. And remember, these two things should be the same, so they both need to be x plus 5 in this case. All right, so instead of writing x plus 5 times x plus 5, let's write this as x plus 5 squared. That equals 36. Right? So now we can solve this. All right, we have something in parentheses squared equals 36. So before we do that, let's just kind of think. If I have x squared equals 36, the way I solve this is I just square root both sides, and I have x equals, and this is the part we all forget, plus or minus 6. All right, x equals 6, and maybe let's just say or. I'm going to say or x equals negative 6. All right, so that's what we're going to do. This is kind of our next step here. So let me get rid of all that. We need to square root both sides here. All right, so a square and a square root, they cancel each other out. So we are left with x plus 5 equals, and now be careful on this one, plus or minus 6. All right, that literally means plus 6 or minus 6. So from here, all right, this is kind of that last step, and this might be a little bit new, or you might not have done this in a while. Make two equations here. I'm going to have x plus 5 equals 6, or x plus 5 equals negative 6. And now solve both of those. Subtract the 5 on both sides. We have x equals 1, or x equals negative 11, right? Which is the same thing we got when we factored. Right? So there you go. That one's done. That is how we solve quadratic equations by completing the square. And again, the whole reason for doing this is when we don't have nice numbers. When these polynomials do not factor, this is kind of the method we want to do. If I gave you this and I said solve it, you would factor that because factoring is a lot easier than this whole completing the square method. But if we look at number 4, this one does not factor. All right, there are no products of 24 that give us negative 8. So let's complete the square instead. So first things first, add the 24. Let's try that again. Add the 24 to both sides. Oh, my computer's not cooperating anymore. All right, add the 24 to both sides. We're going to have x squared minus, I hate this computer. All right, we're just going to do this. I'm making a new page. X squared minus 8x minus 24 equals 0. All right, so we need to solve this by completing the square. I'm going to add the 24 to both sides. So x squared minus 8x, remember, plus a blank space. All right, we got to figure out what's going in that blank space. Equals 24 plus a blank space. What goes in that blank spot? Let's figure it out. I'm going to take this 8 and I'm going to chop it in half. And that gives me negative 4. Now, I'm going to take the negative 4 and I'm going to square it. What is negative 4 squared? Don't you dare type that in your calculator because you're probably going to get the wrong answer. It's positive 16. All right. We have to put that in both sides of our equation. So what do we do next? I'm just going to rewrite it all. X squared minus 8x plus 16. That equals 24 plus 16. That gives us 40. All right. Now, if you factor the left side, this is x minus 4 times x minus 4. That equals 40. All right. If you remember that shortcut I was talking about earlier, right? These things always match. So instead of writing, this step, you could skip straight to here. X minus 4 squared equals 40. Right? And now the process is the same as the previous problem. We need to square root both sides. All right. So we have x minus 4, the square and square cancel each other out, equal. But if you look, square root of 40, that does not simplify, all right? That is not a perfect square. Don't forget your plus or minus like I did. All right. So we would not be able to factor this one because this is some decimal. I don't know what it is. All right. But instead, here's what I'm going to do. I'm going to say x minus 4 equals plus or minus. I'm going to reduce that radical. I'm going to call this 2 times the square root of 10. All right. So we're almost done. What I'm going to do is I'm going to rewrite this as two separate equations. I have x minus 4 equals 2 square root of 10, or x minus 4 equals negative 2 square root of 10. All right. Now, the very last step is to add the 4 on both sides, but these two things are not like terms. All right. So your final answer on something like this is going to be x equals 2 square root of 10 plus 4, or x equals negative 2 square root of 10 plus 4. All right. You'd leave it just like that. Do not try to simplify that. Don't call that 6 square root of 10. All right. That would be wrong. You can switch the order on them. You can call this 4 plus 2 square root of 10, or you could call this one 4 minus 2 square root of 10. All right, but you cannot combine them. Leave your answers just like that. This is your final answer. Right? And there you go. That's how we complete the square. Now, why is this useful? This is useful because we can turn these to, we can use this method to turn these into circle equations. All right. So how do I identify the center of the radius of a circle that's not written in standard form? We complete the square. So this is the equation of a circle, x minus h squared plus y minus k squared equals r squared. That's what we talked about in 12.1, right? So what we have to do is we need to take this equation here and we need to complete the square to make it look like this kind of equation. All right. So there are a lot of these. I'm not going to do all of these. I'm going to do two of them. Just for the interest of time, how about I'm just going to do number 5 and number 7. All right. So first things first, I see an x squared, I see an x, I see a y squared, I see a y, and then I see a number all by itself. All right. So it's kind of set up like our completing the square. The only difference is we have x values and we have y values. So really, what we're going to have to do is we're going to have to complete the square twice. All right. So I'm going to do this. I'm going to say x squared. I'm going to try that again. I'm going to say x squared plus 12x. And then remember, I'm going to put the blank in there plus blank, all right? Some number that we have to figure out later. All right. Now I'm going to do the same exact thing with the y values plus y squared minus 16y plus a blank space equals negative 96. All right. But I have two blank spots on the left side, so I need to put two blank spots on the right side. All right. So let's just go in order and let's just figure out what that's going to look like. So we have a negative, or we need to divide this by a 2. So 12 divided by 2, that gives us a 6. And then we have to square 6. 6 squared, that gives us a 36. All right. Now, we have to do the same thing with the y values. So I'm going to take the 16 and I'm going to divide it by 2. Negative 16 divided by 2 is negative 8. So I'm going to take the negative 8 and I'm going to square it. All right, negative 8 squared is positive 64 on both sides. All right. So here's kind of where we're at. I got an x squared plus 12x plus 36. All right, then I got my y values plus y squared minus 16y plus 64. All right, all of that equals negative 96 plus 36 plus 64. That is 4. All right, so we're almost done. Take this guy and factor it. So I'm going to skip a step here. I'm going to call this x plus 6 squared. And then I'm going to factor just the y's. Then I'm going to have y minus 8 squared equals. All right, now this part. Look at our equation. It's x minus h squared. That's in red here with our x's. Y minus k squared. That's in blue with our y's. This is r squared. All right, so if you look at 4, I don't want to write that as 4. I'm going to write this as 2 squared, right? Because 2 squared is 4. And now from there, we know the center and the radius of our circle. Here is our h value. Here is our k value. And here's r. And the last thing we need to remember is that those inside numbers are liars. So the center of this circle is at negative 6, positive 8. All right, you flip the signs on there. So it's x plus 6. So that means the x value is a negative 6. It's y minus 8. So that means the y value is a positive 8. And then the radius equals 2. All right, and that one's done. Right? So all we had to do to take this standard form of an equation and put it into this, we call this vertex form, was to complete the square. And we just had to do it twice in this case. All right. So not too bad, just lots of algebra going on here. So hopefully, you're able to follow along with that. But let's just do one more. So on this one, it's not in the form that we need it. Notice how you have the x squared on one side, everything else on the other. I'm going to try to keep that x squared term positive. So I'm going to take all of these things and I'm going to move them over to the other side. I'm going to leave that negative 153 there because we have to put that on its own side anyways. So it's already there. I'm just going to leave it alone. So if we just kind of look at this and being very careful with those signs, we have to add 24y, we have to add 10x, and we have to add a y squared. All right, so add that to both sides. And then I'm not gonna write it on both sides. I'm just gonna go to the next step here. But I am gonna make sure I put them in the correct order. All right, so I want all my x's lumped together, kind of like up here, we had the x's and then we had the y's. So I'm just gonna do that same thing here, and I'll try to keep everything color coded for you. So we have x squared plus 10x. And then I'm going to put that blank spot in because we have to put a number in there eventually. And then same thing with the y values. So plus y squared plus 24y plus another blank. All right, that equals, we have negative 153, but we have to have our two blanks in there, plus the x, extra number we're getting, plus the extra number we're getting off the y's. All right, so that's what our setup looks like. We had an additional step here, just put everything on one side. You know what? This is getting long, so I'm just gonna see if you can figure out where I'm getting these numbers from. The first one here is going to be a 25. Right? The second number I'm going to get is going to be a 144. Right? So I'm going to put those on both sides. I see a 25. I see a 144. All right, so really think about where those numbers came from. And then I'm going to factor everything. So I'm going to factor just the x's right now. All right, so this guy turns into x plus 5 squared plus y plus 12 squared. All right, that all equals the other side. I don't have a clue what that is. Um, watch your sign says negative 153 equals 16. All right, and there you go. And actually, instead of saying 16, we have to be careful. This is our squared. All right, so the center of our circle is negative 5, negative 12, because those numbers on the inside are lying to us. And then the radius is equal to, be careful on this one, it's 4. And there you go. And that one's done. And with that, Unit 12 is done. All right, so we'll see you guys later and have a good day.